For any given function at over any interval, there's really only three things that can be happening. Either a function is increasing over an interval, it's decreasing over an interval, or it's staying constant on that interval. And if we were to sketch in tangent lines on the increasing interval, all of those tangent lines would have a positive slope. And that means that the derivative, anytime a function is increasing, would be positive. If a function is decreasing and we sketched in tangent lines, all of those tangent lines would have negative slopes, which means when a function is decreasing, that's when its derivative will be negative. And if a function is neither increasing or decreasing, then any tangent line that we sketched would have a slope of 0, and that means that a function is neither increasing or decreasing when the derivative equals 0. So again, to recap, when the derivative of a function is positive, that tells us that the function is increasing. When the derivative of a function is negative, that tells us that a function is decreasing. And when the derivative of a function equals 0, it's neither increasing or decreasing. And so we can analyze and know a lot about a function just based on knowing some things about the derivative. We can also know some things about what's called the concavity of a graph. So a graph that looks something like this is said to be concave up. And a graph that is facing downward, so to speak, is said to be concave down. Now let's consider what's happening to the tangent lines as we move around a curve that is concave up. So notice this first tangent line on the left is very negative, it's very steep. And as we move to the minimum of our graph, it's going to 0. So we started off as negative, went to 0, and now the tangents, their slopes, are getting more and more positive, steeper and steeper and steeper. So in a concave up situation, what we saw in that interval is that the slopes went from being negative to positive. And more importantly, if we paid attention to the values, let's say that it started off as a slope of -5, and then went to -2, and then went to 0, and then went to 1, and then went to +7. The slopes are increasing. And if we contrast that with what's happening with a concave down graph, we would see that the slopes start off as being very steep and up, and they're positive, and then they get less and less positive, eventually going to 0, and then they get more and more negative. Right? Or to use actual numbers, it might start as, say, being +9, and then somewhere be 3, and then go to 0, and then -1, and then on to -7. Right, so the slopes went from being positive in our example to being negative, but more importantly, the slopes were decreasing in value. Right, so again, to recap, I know that a function is increasing if its derivative is positive. I know that a function is decreasing if its derivative is negative. And I know that it's neither increasing nor decreasing if the derivative equals 0. Second, I know that if a function is concave up, if the slopes are increasing. And I know that a function is concave down if the slopes are decreasing. Right, so we can analyze functions in terms of increasing, decreasing, and in terms of concavity. Let's consider this idea of concavity and slopes increasing and decreasing a little bit more. And we'll analyze the graph of y equals x squared. And I'm choosing this one because we should all be familiar with this parabola. Right, its vertex is at 0, 0, and it's clearly concave up. Now notice that the first derivative of this function would be 2x. More importantly, the second derivative of this function would just be 2. And this means that the second derivative is always positive. It will never be negative. And since the second derivative is always positive and can't be negative, this tells us that our graph, or confirms what we already know, that the graph is always concave up. So whenever the second derivative is positive, the graph would always be concave up, because it tells us that the slopes are just increasing in value. Let's contrast that with a different graph that we should be familiar with, y equals x cubed, where graphically y equals x cubed has this kind of shape to it. And notice that when x is less than 0, our graph is concave down. And when x is greater than 0, our graph is concave up. And let's relate that to the derivative. So the first derivative of x cubed is 3x squared. And notice that that would always be positive for any x value, which means the graph is always increasing. The second derivative of our function is 6x. Notice that our second derivative equals 0 when x is 0. And when x is negative, our second derivative is negative. When x is positive, our second derivative will be positive. And that relates to the concavity of the graph being negative before 0, being concave up, the second derivative being positive after 0. So make sure you have this straight in your minds, these relationships between the first derivative, the second derivative, whether the function is increasing, decreasing, concave up, concave down, and we'll continue to do more work with function analysis.